Welcome back, algebra students, to another video lesson. Today we're going to jump into a new topic called standard deviation and looking at what that really means. So hang in there, take some notes, make sure you get this information down. All of our stats units so far, we've really been looking at this variability in the data set. Right? Like, how does one set differ from the other? How close or how far away are the numbers in a certain set? So that variability is what we've really been investigating. Mean, median, and mode, right? We've looked at how to calculate them. We've also identified which one is the best measure of center and why. So you should be able to tell me which one is best in each situation. Last week, we slowly looked at this shape of a distribution based on box plots. Here's a good diagram to just maybe help you understand which one's skewed or not skewed. Let me do each one of these in a different color. So if you look at, if we tried to draw an outline and a number line in a sense, there's what symmetric looks like. It's kind of even on both sides, where if you look at this one, it looks like its tail is going off to the left, so it's skewed left, versus this one, you can kind of see where it's got a tail that's going to the right, so we call that skewed right. Make sure you know the difference visually in what those look like, okay? And that's what we get from a box plot. Now, we got to be careful and remember in these box plots that, these different dots represent specific numbers. Like all of these dots in this middle row here are all fours, 4, 4, 4, 4, and so on. Okay, and that was a little bit of a mistake we made on our target practice. But really, one of the key ideas here is, can you calculate mean, median, and mode based on dot plots? And can you tell me the distribution, which way it's shaped? Today, we jump into something called standard deviation. Deviation means, how far away does it move and disappear, or that variability. And really, that's what we're going to have to calculate. Can we calculate the standard deviation for a set of data, with or without technology, and use it to determine the variability in a set? How close is it, or how far away? What is a standard deviation? Now, again, I'm working out of your stats packet. I think it's on page 17 right now. Standard deviation is a measure, it's an actual number. We can measure how spread out the values are in a data set, right? So we can actually calculate and assign it a number that describes how spread out they are. That number is called standard deviation. How do we calculate it? Well, that's what we're going to look at next, okay? How do we calculate the standard deviation? The first step should be relatively easy. We take our data set and we just find the mean, right? We've been working on that. You know how to find the mean, so we should be good there. Once you find the mean or the average of that set, here's where it gets a little trickier. We then have to determine how far away is each value from the mean. If I got a mean of 10 and my number is 9, that means it's 1 away, right? So it's 1 away. And we're going to have to do that with every single number. After we have done number 2, and we found out how far away each value is, we then square each of those numbers. So if it was 1 away, I do 1 squared, and I get 1. If it was 2 away, I would do 2 squared to get 4, and so on. Once we have that step number 3 done, we're going to add all of these results from step number 3 together, right? Add all of those numbers together. Once we've added all of those numbers together, we're going to divide by one less number than the values that are in the set. So like if there was 10 numbers altogether in the set, I would divide by 9. If there was, 8, then I would divide by 7, and so on. All right. Once we've gotten that done and we've divided, we're going to have a number that we take the square root of. All right. So we have all of these processes, and then at the end, we would take a square root. Whew, that's a lot. Whoa. Right? Like, that's a lot of information to undertake. Don't write those steps down, because what program is going to be our best friend for finding information in stats? I hope you were able to answer Desmos, because that's really what we're going to. We're going to go to Desmos, okay? So here's what you probably should write down in helping you find the standard deviation of a set. And remember, we've done part of this already by putting sets into Desmos so that we could find mean and median. And it's a very similar process. We're going to go to Desmos, and then we're going to create those sets. And sometimes we might have two sets, right? So maybe the first set, we're going to pick a letter, and we're going to go A equals bracket number, comma, number, comma, number, comma, and so on, right? No spaces. And if we have a second set that we want to compare, we're going to do a second set on a new line, and we're going to type in a different letter. It's got to be a different letter than what you used in the first one. B equals bracket number, comma, with no spaces. Okay, so we're going to put those sets in just like we did in the past. Once we have them in, now we can use a special code, right? On the next new line, and I'm going to demonstrate this in a moment. On the next new line, we can type in STDEV, standard deviation, STDEV, parenthesis A, parenthesis, and it will give us a number that calculated the standard deviation of set A. If I wanted to do it for B, I would repeat that process, but instead of parenthesis A, I would use parenthesis B, and it's going to give me a set number. Okay, then if you forgot how to find all of that, don't forget there is that keyboard function in the bottom left that you can pull up, click on functions, and then click on the word stats, and then you can find standard deviation there, and it'll punch the code in for you. Okay, so these are the steps you probably want to write down. This is a good time to pause this video and make sure you have those down. All right, now let's take a look at an example and how this applies when we go inside of Desmos. So this is out of your packet. I want to say it's on page 18 or 19, talking about the temperatures in Fahrenheit for two cities, like the average temperature for two cities each month. So New York City has these averages, and then San Francisco has those averages. The first question that we have is, what is the average monthly temperature in New York City per year for 1 year? What is the average monthly temperature in San Francisco for 1 year? The best thing that we have going for us is to use Desmos. And so what I've done is I have hopped over and already input New York City and their values as A, and San Francisco and its values as B. So here we go, right? 12 elements and 12 elements in each list. We're talking about the 12 months of the year. So the first question was to find the mean. So I'm going to type in the word mean, parenthesis A, parenthesis. So the mean for set A was 63. So the average temperature for New York City is 63, according to this data. And let's check it out for B. So I'm going to go to a new line. And notice every time I'm going to use a new line, just because it helps me keep all of my data nicely organized, right? So average for B, the mean for B was 64. So San Francisco was 64. So if we look at this, it would appear that San Francisco has just a slightly higher average, right? 1 degree. Now, again, notice when I typed all of these in, here was that formatting. No spaces, B equals bracket, no spaces. Okay. So that was question 1. Now, I skipped a few questions from the packet. However, part E is asking us which city is the mean a better indication of a typical temperature and why. Well, now we have an official way for us to kind of calculate, right? When they ask us for if the mean is better, that's what they're talking about for standard deviation. We can look at the standard deviation to tell how much variability the data has. And so again, I'm going to grab a new line over here, and the code is STDEV, standard deviation of set A. 16.5, right? So New York has a 16.5 STDEV, standard deviation. Let's go figure out what San Fran has for standard deviation. Okay, once again, if you forget, like you don't remember, new line, you don't remember that it's STDEV, come down here to the keyboard, pulls up with a nice little calculator. You click on functions. We want to go to stats. and we are calculating right there, STDEV, standard deviation of group B is 4.29, 4.3, right? If I round it to the nearest tenth, 4.3. So it's got a standard deviation of 4.3. Before I continue, if you have questions on how to calculate and how to enter any of this into Desmos, you have to make sure that you reach out, because this is part of the test. Like, you're going to have to know how to do this on a test, and you're going to have to take a screenshot of all of this information over here on the left to show that that's how you've done it, how you've gotten the information. Okay. Now, we've got two numbers for standard deviation. New York has a 16.5. San Fran has a 4.3. What is really happening here is we have to understand this conclusion. The larger the standard deviation, the greater the variability. The larger the number for standard deviation, the greater or more spread out the data is. Meaning it's going to vary more often, right? So if we go back and you look, New York had a standard deviation of 16.5. San Fran had a standard deviation of 4.3. That means the temperatures in New York are going to be more spread out and farther apart over time, versus San Francisco is going to be much closer over time. Okay? And that means we have to be able to answer some questions. So, for example, when comparing the standard deviations of New York City and San Francisco, which city would Robert choose to move if he is interested in having a lot of a variability? If he does want the variability, which one should he choose? Well, he should choose New York, because that standard deviation is greater. Because the standard deviation is greater. If he didn't want a lot of variability, then he would have chose San Francisco. But because he does want a lot of variability, he would choose New York. And that's this key statement right here, right? I would make sure that you have this written down somewhere so that you know the larger the number is for standard deviation, the greater the variability, the more spread out it actually is. That's standard deviation, folks. You're going to get some practice problems to work on today, just a couple to help you go through that process of finding it. Make sure you know how to use Desmos and you reach out if you need to. Again, we're coming down to the end of the semester. We got like 7 days left, 4 this week, 3 next week. So make sure you tune in for our live session at 8 a.m. tomorrow morning, where we're just going to review a little bit of what that end of the semester looks like, signing up for classes for your next sophomore school or the 2021 school year. And then we'll also begin to review for our stats mini test, which is the 14th. So if you have questions, make sure that you reach out. Otherwise, folks, until next time, stay safe.